All right, thank you guys for joining today's webinar, Why DNS Scalability is Critical to Service Reliability. Your speaker today is Apposite's own Dan Hernandez. Welcome, Dan.
Hello, everyone. So, good day, everyone. My name is Dan Hernandez, and I'll be hosting today's Apposite Technologies DNS Scalability webinar. I have a long background in performance monitoring and application monitoring suites, and this also includes pre-production QA tools relating to network and WAN emulation, along with traffic generation. Apposite Technologies, we're a company that's based in Los Angeles, founded in 2005, as you can see. And we support over 3,000 plus customers in a variety of verticals. And realistically, we are kind of agnostic to these verticals because our capabilities are that wide. And I'm sure we have a host of folks that find themselves in a few of these verticals today. So what we're trying to message for today is going to be how we can help Apposite with their capabilities in the DNS arena. But what we want to really have everyone understand as the goal is to help companies develop and deploy new technology with confidence. Our performance testing tools live in your test lab and enable you to test with real world conditions to help you deliver the best possible user experience. Hence, our user interface assists in easy replicating a production network, the same for injecting realistic application traffic, be it stateful or stateless. And it provides you the ability to have deployment measurements, empirical information to make very insightful decisions on performance capabilities, capacity, and scale considerations. We also provide the running of emulation or traffic generation separately and or together. So today what we're going to do, and with my audience, I know there are a few out there that already understand the complexities of DNS, but what is DNS? And DNS at its fundamental human layer is just the ability to have an IP address assigned and allocated and aligned to a host name. The host name as we know it, yahoo.com, apposite-tech.com, is realistically an IP address. So what DNS is hierarchical capabilities bring to bear is resolving that IP address and or that name to a device on the internet to load that web page for you as an end user. So an IP address is given to each device on the internet, and the address is necessary to find the appropriate internet device. So what we want to show you going forward is our ability to exercise your DNS architecture and to further isolate any kind of bottlenecks you may be having today. So in the world of DNS, we continue on, it's how quickly and how succinctly your architecture can traverse the hierarchical capability of DNS, meaning if you apply an IP address and or a name and the system begins to check for that name, what it will do if it cannot, it will go to a recursive resolver who will attempt to further the effort to acquire a find of the web page for you. So we'll talk about different types of DNS servers in a little bit, but really it's a very intricate architecture that is always seeking and hunting to provide you with resolution to the name and or IP address that you're hunting for on the web. So what we come to find out with the voluminous rate of growth of the internet is what can be a problem is the growing demands of your DNS architecture and realistically across the globe. So when we're hit with poor networks, bad communications, bad connections, excessive latency, these types of things strain DNS server performance. And these are capabilities we can replay and bring to bear inside our demo capabilities. So cache misses where you begin to churn at the DNS server is another area where we can help you provide bottleneck highlights to bottlenecks, and then provide you the instances of that data to show you where you can make some changes on your DNS architecture. And then once again, to scale, we are a very robust capability with for testing capabilities. So if we need to scale to an extraordinary amount of hosts, such as millions, and or send down millions of queries per second for these kinds of tests, we can also do that and accommodate that for you. So the test configurations are variable. You can begin specifically off one of our test beds with a one-to-one configuration where you may want to be doing a high performance test. And if that's may be the case, then you would just architect and send that information down to your DNS server or your resolver and await your information, your runtime analytics review, and see how you're doing with those kinds of high performance, high scalability tests. In a distributed fashion, if your lab can support a variety of DNS servers and to mimic a really heavy DNS architecture, you can also do that. We support quite a few densities of appliances and port densities, so you can once again have different teams utilize those ports to run tests against different DNS servers. So today's configuration is going to support just one single port. And what we're going to do is put that port into a full duplex mode. And we're going to be speaking to a Ubuntu machine that's hosting a DNS responder service. And with that, we'll show examples of queries sent and some analytics that we hope you find useful when you're performing your DNS inquiries, your testing. So that's what we'll be doing with respect to DNS from the lab's perspective that I'm going to be supporting. So, and that brings us to DNS Storm. DNS Storm is a new entry into our software modules within our traffic generation capability. And what that's going to bring to bear is, once again, scale. The scale at a very large rate. So 1 million emulated DNS clients capable at up to 3 million queries per second. The system we have today will be a 10G unit, so or 1G unit, my apologies. And so what we're going to do there is just send a stream of requests, a request on IPv4, and then we'll review the statistics, and you'll get an idea of how we can easily run the test, build the test, and then review that test. So at the end of this bottom of this slide, we're talking about 500 million of the world's most domains. We have a master record via web crawler capability. And with that, I'll go over that in a little bit more detail during the demo, but it is a file that is part of the offering with traffic generation for us. And you'll see how we utilize that file and how you can edit it to have certain information within concerning domains, invalid information, malformed information with regards to DNS testing. So here's a sampling that we have today that you'll be reviewing during the demo. And we continue to work on the depth of all our query types. And these are right now some of the supported DNS return codes. So in effect, when the web crawler file is issuing a malformed query and or invalid query, the return codes will obviously fall into line to allude you to that fact during the test. So I had spoke about the master record creation. So this is a file that we keep updated, and today it sits at about 500 million entries, and they are a smattering of the latest domains that continue to be sent out onto the wild. And so we'll be generating that file at a specific rep rate for you in the back end, and that allows you to go ahead and stay cognizant of all the new domains that are coming out, and you can test against them. So a lot of information here, but these are a lot of the KPIs that we're going to be bringing to bear with our DNS testing capability. DNS Term is specifically designed to test out these KPIs and stay and help you really vet out the hierarchical structure and DNS protocol. And so that's what we're going to be showing today and demonstrating today. So we're going to be moving to a demo now. And so I'm going to be giving you an example of what we do with DNS Storm. So what you're viewing right now is our dashboard. Our dashboard is consistent with our offering in the traffic generation, regardless of whether you're looking at for DNS or other of our software modules, which I'll show you shortly. I've created a DNS testbed, and right now I'm just going to pause it so we can walk through a configuration in total from start to finish. And we'll just take a second for it to refresh itself here. Okay, and we'll start from the very beginning now. So to create a testbed, very straightforward. Just hit our testbed radio button, and up come the 5 pillars, that software modules that now support traffic generation for Apposite technologies. So we can begin with just a little brief on Traffic Engine. Traffic Engine is really to benchmark raw packet level performance of network devices. And we have about 150 signatures, packets that we can run across a variety of tests for you. And that's how, to get a level set of your total network performance, that's what we would be doing with Traffic Engine. For App Playback is unique, where you can provide a PCAP of your own recording, and then we amplify it at scale, make it a very robust test. So we'll record and replay real-world traffic PCAPs that you have in your library, in your lab, emulate clients and servers on both ends, and then we would go out and you can do a lot of exhaustive testing against, let's say, items such as WAN accelerators, SD-WAN gateways, so on and so on. With App Storm, we have about a library of over 1,000 PCAPs where we're realistically sending out valid performance and application-aware information of application-aware devices, firewalls, DDoS readiness devices such as IPS, IDS. And what we're trying to do there is have your systems via our library be aware of these kind of devices and this kind of traffic that you want to put on the network. So you can mix in some malware streams to measure network effectiveness if you'd like. And, you can go down a path towards security awareness profiles. And I think that's everything for Session Strike. Let me talk about Session Strike just real quick. Session Strike realistically is to, establish and tear down TCP and HTTP connections. And this way you can verify load balancers, firewalls, and really hit these systems very hard with our robust and our density to scale. So today we'll obviously be talking about DNS and the application. Once again, that software is DNS Storm. So back to the configuration, back to the dashboard. This system that I'm using right now is supporting 2 ports. We're only going to be using port 0, and I've reserved that port right now for that test. This is how test engineers would come into the system. They reserve ports depending on the density of the system that they're using and however many ports they have to run their tests. I'm just going to select DNS configure. And this is the test that we're going to begin. And this is our wizard now. This wizard will walk us through the creation of a full test bed for running your stateful tests or your stateless tests. But more importantly, here's the port associated for the run today, for our test today. I'm going to use 100% of the bandwidth, and it is in full duplex mode. And I'll just hit next to continue. And here's our host configuration setup. It's very straightforward. and very intuitive capability that we provide you here from Apposite Technologies. We can start with the source and MAC addresses, which we can put in a random and or a custom profile. Encapsulation types, if required, for other types of testing, but for today's testing, we'll just be using none, but there is VLAN capabilities and so on there. We're going to be using IPv4. Today's test is only going to support one host, but it has the capability of amplifying that to 1 million. And just as if I was using another software module, if I was going to replay a PCAP and that playback, I can once again do the same. I can amplify the amount of hosts. So amplify to extremely large scale. The IP addresses specific for today's tests have been applied here. And so that would be realistically all that's needed to create a test. In your lab, if you're supporting a gateway to get downstream to other devices in the lab, you can go ahead and put that IP address in here and utilize that gateway IP address feature. I'll hit next to move along. And so here's our stream. What's interesting here is, once again, it lets you know what your selections have been made, port 0, as we had stated before, utilizing IPv4. But specific to DNS, we're going to be sending out just an A record today, a host record today. And so we'll just go ahead and use that. And as you saw, we have a bunch of other DNS queries that you can send downstream, and we have other little information capabilities here to exhaustively test out your information you send downstream. And that would be inner frame gap and inner burst gap capabilities here if you want to assign those or put those into test. So here's our traffic profile. And this is very important because we talked about the web crawler file, the master file that we provide on the system with 500,000 records. And here's where that is consumed and that is made available to the system. So here we have a mix of 50% valid queries to 50% invalid queries. If I was to highlight one of the sides of this pie chart, it would then give us another rendition of what is assigned to those sides of the pie chart. So here we're sending a mix of malicious traffic, malformed traffic, and malformed packets. And so that is what the system downstream is going to be, that's going to be received that and see how we respond to that. And as we had stated before, we're just sending a type A record. On the right side view of this window, we have the load profile capability. With load profile, you can take your runs and you can implement a test durations. As in intervals, you can set up 4 iterations of maybe 4 1-minute tests or 5 30-second tests. So that's totally configurable to you as the test lab engineer. And you can sway the load profile to be more centric to how it ramps up for the packets to be sent and or queries to be sent. And so you can slide this window to create the load profile, traffic profile that you really want to push downstream. So for our test today, for our demo today, we're going to not use the load profile. This will be in an infinite loop then. Once again, if this is not selected, this will put it into an endless state. So the last step in the wizard that we have is summary. So my selection of next will bring us to the summary page of what we have selected for criteria for our test run. So the next thing to do right now is just hit start test. And we'll wait just a few seconds and our test will begin. So just going from left to right with the amount of information that you're going to be receiving, we have 4 different types of analytics for view, and those are aggregate statistics per stream. We have an offline analyzer. When we stop the tests, certain columns will now be made available of data sets and data metrics, and then we have our logs. And the log files are quite in the background will be PDF files or CSV files. There's a different way to consume those, various ways to consume that information. From port 0, the information that we're providing you in this run is, right now we're topping out at about 1.48 million queries per second. And so we're receiving 1.2 million queries per second back. The disparity in those numbers is due to the fact that some of the information we're sending downstream is malformed and some of those are invalid, so nothing would be coming back to the DNS engine as far as a rate is concerned. Our throughput is near 1 gig at line rate. You had noticed that my port 0 was 100% bandwidth was set, and that was for 1 gig. And we're receiving just a tad over 1 gig, and that would be payload coming back with more information. It's payload. We have 2 specific graphs during the aggregate statistics run, and that would be packets per second, which aligns to queries per second right now, and then our throughput graph, where you can hover and then take views into what is occurring on the wire here. So we have also a capability of statistics per stream, and this is where you should be able to consume some of the error codes that you have sent down to be tested by your DNS capability. So here we're telling you that you've received quite a few return codes on no error right now. So we have some of these columns will be populated during the stop of the run, but moving on, we do have an offline capability on our offline analyzer where I was to stop the test. Then I would have the log files be generated, and then this offline analyzer would be giving us this basically the same information as you see right here. The log capabilities, because I've been running DNS for quite some time leading up to this demo, is just a gathering of information that most all of us need to make sure that we're receiving the right information from our capabilities in the tests. We do have a data capture capability, so this runtime data capture can bring back an RX and a TX PCAP file associated to that specific port, so we can provide for that to your team. And so with that said, this is what we have available to you today with regards to a run. So I hope you find this informative, and you do reach out and talk to us about, our capabilities and how robust we can be and how we can help you in that lab environment. So I'm going to bring it back to Becca, and we're going to, my apologies. So she had brought up the fact that if anyone has any questions to provide us, Becca's going to let me know what we have available for answers or questions right now, and I can provide some answers.
Yeah, so if you guys want to type it into the Q&A box, we'll be sure to get to those. Looks like we have one now. How many port densities do you guys provide for this application?
So our density or our density for formats for appliances, we provide 10G. We have a 10G2 and a 10G4 capability. So when we say 10G2, 2 and/or 4, we're talking about pairs of ports. So once again, you can put the appliance into a multi-tenant capability in your lab. So now multi-tenants and/or more test teams can be on the system running robust testing mutually exclusive to each other. That's why we have that reserve a port criteria when you're building your test beds. I hope that answers your question.
Okay, and we do have another one. Do we support a RESTful API?
So the answer to that is yes, we do provide for a RESTful API. We support various scripting languages, Python, Ruby, so on. And anything and everything you had seen me do manually on today's demo via the dashboard, and the UI wizard is capable to be instrumented via a RESTful API. And obviously that alludes to automation. So the answer to that is yes, we can provide for total automation of our test runs.
Great. So it looks like that's all we have for now. I'll give it just one more second to see if anyone else wants to write a question. Otherwise, if you guys think of anything offline, we will definitely be available to answer any questions if you want to reach out. Here we just have a few more resources Apposite provides regarding DNS. So yeah, thanks Dan so much for your presentation today.
And thank you everyone for coming to the Apposite Technologies DNS Scalability webinar. I do appreciate your time today.